Well, I think I'll start by introducing myself. So my name's Alicia Newton, and I work with the Geological Society of London. So over the last year, we've been working with some of our society counterparts from across Europe on a program that's been designed at helping young people to discover the earth sciences and geoscience, and particularly young women and girls. So as part of that, I'm so pleased today to present Meet an Earth Scientist. And today we have Leanne Melbourne here with us, who'll be telling us all about her work, understanding how climate change affects marine creatures and marine ecosystems. So because we're recording this today to put it up on YouTube later, I'll ask that if you have any questions, you pop them in the Q&A box at the bottom of your screen, and we'll answer them once Leanne has finished telling us a bit about herself and her work. So over to you, thanks.
Thanks, Alicia. Hi, I'm Leanne, and I am a lecturer at the University of Bristol. I lecture in micropaleontology, so this is looking at tiny marine fossils and analysing their shells and the chemistry of their shells and their sizes to reconstruct past climates. So we look at things like foraminifera and coccolithophores. But my research itself is a little bit different to what I teach. And as Alicia said, I look at the effects of climate change, so ocean warming and ocean acidification on marine organisms. And I more specifically look at marine calcifiers. So these are organisms that precipitate calcium carbonate in their shells and their skeletons. So I've got some here. So this is coralline algae. And this was what my PhD was focused on. So these are a type of calcified seaweed. And so they have like a similar ecosystem function to like corals. So they provide habitats to a wide range of organisms. And my research mainly focuses on the impact on their structural integrity. So does a warmer, more acidic ocean cause them to form weaker skeletons, which would impact their function as habitat formers? So kind of looking at that kind of function of providing a habitat to a wide range of organisms. So how I do this is I use computer modeling. So it's a technique called finite element analysis, and we can model changes to the internal structure and see how this affects their overall structural integrity. And so during my PhD research, I looked at different species around the UK. So we had species from Scotland and species from the south of England, and looked at differences in their cellular structure and modeled these changes. And so what we saw was that species from Scotland seem to be forming slightly more robust skeletons. They have stronger skeletons than the species from the south, and this was south of England. And this was all to do with the thickness of their cell walls in their internal structure. I also looked at through time. So I worked with the Natural History Museum in London, and I looked at specimens of coralline algae that were collected about 100 years ago. And so we looked at how the cellular structure changed through time. And we saw differences in their cellular structure over time, which caused a weakening of their structural integrity, but it's not as large as what we see between species currently. And I also got to look at, with the increase in temperature, we have there's predictions for more stormier seas, so an increase in the intensity and the frequency of storm surges. So we looked at what does like a stormier sea look like with larger wave speeds, and modeled those kind of things as well to show that under increased stormier conditions, these organisms are under more pressure. And especially with these type of organisms, because as you can see, they actually live unattached on the seabed. So they're more mobile, so they can move about and interact and collide with each other. So wave speeds are very important for these organisms. And so that's what I kind of did in my PhD. And now while lecture, so I took some time out and worked in science communication for a bit, actually across the road from Joel Sock at the Linnean Society of London. And I worked as an events communications manager. And I only recently came back to academia and started this job in March. And so my research now, I'm still looking at these coralline algae, but now we're looking into deep time. So I'm working with a colleague that's looking at changes in their cellular structure across longer term environmental change. So the Paleocene-Eocene thermal maximum, which was about 56 million years ago, was a time period in a geological time period where we had like intense warming, and so we can see changes in the structures for corallines, fossil corallines, before this event and during this event, and we can see that those changes in their cellular structure are leading to a weakened structural integrity. And then I'm also applying these kind of methods, these modeling methods, to other marine organisms, such as bivalves like mussels and benthic foraminifera. And so ultimately, well, I'm looking at how climate change affects the structural integrity of marine organisms, marine calcifiers, and how this impacts their function as habitat formers. So I've got a few slides for you to show you. So first of all, so this is a picture of a rhodolith and mel bed. So this is like this coralline algae bed, and we can see all these brittle stars here, so showing their high diversity. And then I guess what I wanted to finish off was why I love what I do, and why I came back to it. So I did my PhD and then left for a bit, but then realized that actually I really loved academia and wanted to come back to it. And the reason is because it's so great. I get to do so many different things on a day-to-day basis. So in the top left-hand corner, here's me doing some field work in Italy. So it was a monitoring project looking at coralline algae. So that's me trying to count coralline algae while being pushed against the rock by the waves. So that was an experience. I get to talk about my research to other scientists, to the public. So that's me on the right here, giving a public lecture on my PhD work. Because I get to use lots of different types of specimens, so stuff collected today and stuff that was collected in the past, I get to work in museums. So this is me in the bottom right-hand corner working at the Natural History Museum in their herbarium. So a herbarium is where they store plant material. So that's really cool because there's some really interesting collections there. And then this is me at home during lockdown doing some modeling. So we've got a model of coralline algae in the background. So I get to do a lot of things. I get to do field work, I get to do communication, working with the instruments, doing analytical work, so using lots of different types of microscopes, and then the engineering side of things with the modeling. So yeah, that's what I love what I do, and that's a bit about me. So I'm happy to take any questions.
Great. We've got a few coming in, so I might start with one of my own. But
yeah,
when did you know you wanted to go into this field, and what was that like for you?
So I guess I had a conversation with my mum a while back, and apparently when I was younger, I always wanted to be like a marine biologist. I don't really remember this, but so yes, that was when I was probably about 6 or 7 or something like that. But since then, I kind of never wanted to go into it and kind of just fell into it, I guess. So to give a bit of a background to how I got to my PhD, I went to Bristol and did a chemistry degree because I really enjoyed chemistry at school and I was good at it. So I took on chemistry. And then while doing chemistry, I did a year in industry and I worked at a pharmaceutical company, realized I didn't like pharmaceuticals. So then, because that's what I thought I would do with a chemistry degree. And then came back, and in my final year doing my master's project, I was working in the environmental chemistry bit. So, and really enjoyed the environmental chemistry, the ocean chemistry and its impact on organisms. And so then kind of from there, through discussions with my supervisors at the time, was like, oh, a PhD would be something that I think you'd be good at. You did really well at the master's. I never thought I was going to do a PhD. So, and then through discussions on that, I worked out that my interests were ocean chemistry and its impact on organisms and impact on biology. And so through discussions, I realized I needed to switch departments, and there was a really interesting project on coralline algae that I found in the Earth Sciences department. So then I applied for that and got that, and that's how I'm here. But yeah, it was a little bit of a roundabout way because I never really thought that would be my career path. I remember being in school wanting to do medicine, and going to a medicine open day when I was 16 and absolutely not liking it at all, and being like, do I really want to do medicine? What do I, and then so I came away and I was a bit like, oh, I have chemistry, biology and maths A levels. What do I do now? Because I'm not going to do medicine and I don't really know what to do anymore. So yeah, it was a bit, yeah, not like knew I was going to go do it from the beginning. Yeah.
Great. And so I think one of the questions was just about A levels. So you've gotten that down.
Oh yeah. So I did biology, chemistry and maths A level. My AS level, I did English Lit as well, because yeah, but then had to drop that.
Great. And so we have a question about your work, and that's how can we prevent acidification from occurring and assume prevent ocean warming?
Oh, okay. That's a big one. So it's all to do with rising carbon dioxide emissions. So there's been lots of conferences and talks and commitments by governments all over the world to try and limit the amount of warming that we're doing. So carbon dioxide is a greenhouse gas. So what it means is that it like stores heat energy and re-radiates it back over the earth. So it's like a bit like a blanket. So it's like keeping that heat in and like keeping it like warm. And so we see that warming in the ocean. And then with the also as well with the carbon dioxide, it dissolves in the ocean and changes the chemistry to creating a acidification event. So yeah, basically it's about us cutting down our emissions. And the only way we can do that globally is by like policy and government enforcement kind of thing. We can all do our things. We can all do things individually, like cutting down on our flights and using cars and recycling and sustainability and those kind of things. But ultimately, the real goal, it has to come from government and policy, I think, to really make a difference. But there are other things that we can do as well. So kind of some of the stuff that I'm looking at now as well is the impact of multiple stresses. So not just thinking about ocean warming and acidification, but also, so these organisms, they're really susceptible to smothering by like silt and sedimentation, and also looking at the idea of like nutrient stress. So if we've got lots of runoff of nutrients, how does that affect the organism? And if you can alleviate, so if you can kind of help those stresses by changing like farming practices and things like that to stop those kind of runoffs into the system through rivers, that might help organisms adapt and acclimate to warming acidification. So we might not be able to stop it, but we might be able to help them in other ways to deal with those kind of stresses, if that makes sense what I'm trying to say. It's hard when you can't actually talk to the person who's asked the question.
So another question is, did you see any of the impacts on biodiversity when you did your field work?
Not personally, but so I have the organisms that I studied, because they're important nursery grounds to commercial species of scallops. Scallop dredging used to be a thing for these organisms, and they're actually now protected species. So scallop dredging is like these massive metal rakes, and what they used to do is like crawl through the beds to like capture all the mussel and the scallops. And so yeah, so that's been banned now because they realize how important these organisms are, and they've got really slow growth rates. They're very fragile ecologically. So scallop dredging has actually been banned, and these organisms are protected. And through doing my field work and my research, I was trying to find there was okay, so where are we now, 2020? So I'd say about 15 years ago, there was this bed, and I was looking at trying to find different areas around in Scotland that I could sample from. And there was this bed that they were talking about, this merle bed, pristine. And then all the literature kind of stopped, and I was like, so what's happened to this bed? Like, where is this bed now? And basically it's just disappeared because it's been heavily like farmed with the scallop dredging, and it's just, yeah, the bed's no longer there. And it's a similar sort of thing with some of my time series. So one of the areas I was looking at, because we had specimens in the Natural History Museum from 100 years ago in that area, we wanted to go back there. And then, yeah, the bed's not there anymore. So we are seeing those kind of things through research.
And so, in your opinion, what is the biggest consequence of ocean acidification?
Okay, what is the biggest consequence of ocean?
Just a little question there.
Oh, these questions are huge. Oh, the biggest consequence of ocean acidification, I would say its effect on calcifiers. So having a more acidic ocean makes it harder for marine calcifiers to make their shells, to make their skeletons. So if they're having to put more energy into that because it's more difficult, then that's losing energy from other places that they would need it to grow and to perform their function. So I would say that, but I don't feel confident saying that, because I feel it's all interconnected. So like warming is a big issue in certain aspects, and then also the idea of deoxygenation in the ocean. So it's all really interlinked. So it's all affecting organisms.
Great. I'll give you an easy one this time. But do you tend to work with other people often or on your own?
I work a lot with other people, actually. So whenever you're learning like a new technique or a new instrument, you're kind of learning from somebody else. So they're helping train you up, and then you end up collaborating with them. So for my research, it's highly interdisciplinary. So I use a lot of different techniques that aren't necessarily known for that type of research. So what I found was that I would be collaborating with the person who really knew the methods and the instrument very well, but didn't know the organism and the way I was applying it. So it became a collaborative effort where they were learning something and I was learning how to use an instrument. And then, yeah, so now I've got these techniques on modeling, but mussels and benthric foraminifera aren't my speciality. So I'm working with people who do know those things. So it is all a collaboration. And especially as you get further up in academia, you're working a lot with students as well. So you have master's students you do projects with them, and PhD students. So you're constantly collaborating with different people.
Great. And so what is your favorite aspect about what you study?
I think for me, actually, my favorite aspect is interacting with people and talking about what I do. So part of the reason I left science communication was because I did miss my research, but I also missed talking about my research. So yeah, I liked talking to people about what I did, and I found that the best part, because when you start talking to people about what you do and you see that they're interested in it as well, it like really makes you feel like what you're doing is worthwhile. So yeah.
Great. And so back on the more science side, here's one. What are your opinions on iron fertilization in an effort to reduce ocean acidification from rising carbon dioxide levels and temperatures? Just, they're getting the good.
I know.
Stuff. Great question.
So, yeah, so there are studies and there is research into basically dumping a whole load of iron into like the Southern Ocean and seeing how that stimulates productivity to draw in the CO2 and draw it down and store it. So, okay, I don't know too much about that, but from what I have read in the past, a lot of the research has shown that if you model the remineralization of the carbon dioxide, it's actually quite a short cycle. So yes, you get all that bloom of productivity, and so they're drawing in a lot of CO2 and gets packaged in as organic matter and sinks. but within about 60 years, it gets remineralized back. So you're not actually storing it long term. So I think there needs to be a bit more research on that front of how that could actually work, because currently it's not a long enough sink. But that's all I know about it. I'm not an expert on fertilization.
Great. And so how has the pandemic affected your field research? And I guess research more broadly too.
So field research is not happening. I'm quite fortunate. So yeah, so as I said, I started this job in March. I literally turned up at university on the Monday and they were like, yeah, we're closing on the Friday because of the pandemic. So it was a little bit intense. But yeah, so for me, because I do a lot of modelling and working with lots of colleagues here in Bristol who will have scanned a lot of material, I've been okay because I can still do the modelling side of things. And yeah, so I haven't actually needed to do any field work. But yeah, even if I wanted to right now, that would not really be an option. I've been working with other colleagues and getting them to send me material as well, because as I said, corallines are protected. So you have to get certain permission to sample those species. So it helps if people already have material that you can just be sent. So that's what I've been kind of doing at the moment as well. Yeah.
And here's one. Do you dislike any aspects of your work?
Yeah. So writing papers is not fun, but you have to kind of do it. Publishing your research. Yeah, I guess. Yeah, I'm not really a fan of writing papers, but you have to do that. And then also as well, when you write papers, they go through a peer review system. So what it means is that you send your paper off to a journal and then you have different people who will critique your work basically. And sometimes they're just not nice. So, and also you get a lot of things back and you're like, you really didn't understand what was going on here. And so yeah, trying to like fight and prove the worth of your research. It's the same with writing grant proposals as well, because I'm currently doing that and trying to write proposals to get funding for new research. And you're constantly being critiqued about why you're doing this and why you're doing that, and trying to prove the worth of your research and yourself as well. So I'm not that good at that. So that's probably what I don't like.
That's why I'm not in academia, to be perfectly honest. So I understand that. So yes, I'll finish off with one last one, which is, have any particular marine animals been affected from ocean warming or acidification so far?
Yeah, so I can't think of any particular species off the top of my head, but we do see distribution changes. So we are seeing certain species of like seaweeds moving, their distribution is moving further to higher latitudes due to warming, because all organisms have this thermal optimum. And so if they're being found in warmer conditions than what they're actually used to and what they like, you see these distribution changes moving further polewards. We see it with the copepods. So there is data out there that shows that warm water species moving further, moving around the UK, so moving from like Europe, so like Spain, that sort of way, moving up into the UK, these warm water species, and certain species moving further to Scotland. So we see distribution changes due to warming. Acidification is a little bit more difficult because we are seeing a change in the pH. At the moment, it doesn't seem to be drastic enough to cause major changes. But the predictions show that if we continue this way, then we will see those changes, because currently we're still above the saturation state. So we have the saturation horizon in the ocean, which basically means if you're below it, your calcium carbonate dissolves, whereas above it, you can actually build your calcium carbonate shells. And so we're still on that level where organisms can still build their shells. There are predictions based on our business as usual, or if we keep going the way we're going, that certain areas of the ocean will be undersaturated. So then you won't be able to have calcifiers calcifying in those areas, but we don't see that yet. Yeah, I think that was that all of the question? Okay.
Great, and I'll just do one more, and that's how have deep water reefs been affected?
So I haven't actually, this is one of the proposals that I'm writing at the moment, because I'm going to look at cold water reefs. So I want to look at Lothelia pertusa. So it's quite conflicting, actually. So there are certain studies. So Lothelia pertusa is a cold water coral that we have around the UK. And there are some studies that have shown that increasing the CO2 levels, lowering the pH, they are still able to calcify because they have a calcification fluid and they're able to upregulate that and calcify, because they calcify internally. They can change the pH of this fluid to make sure that they can continue calcifying in acidified conditions. So yeah, there's some research that shows that, but then there's other research that shows increasing CO2 is having a negative effect on their calcification and changing their porosity. So like how robust their skeleton is. So that there is stuff out there, but at the same time, these cold water reefs, that a lot of research is now happening on them because we don't actually know that much.
Great, and I think with one eye on the time, I'm going to ask you one final question, and that's for anyone watching who wants to get into this field. What would you tell them about what they need to do, study, love? Like that. Words of wisdom.
Yeah, words of wisdom. So if you have a real interest and you really love this topic, then I'd say go for it. PhDs, yep, they're tough. But if you enjoy what you're studying and if you enjoy learning and finding out new things, then you'll be fine. And yeah, it's all just about having an inquisitive mind and asking questions and just wanting to find out as much as you can. So if you like doing those kind of things, then yeah, science is for you. If you're interested in the oceans and interested in finding out all these questions, well, it seems like everybody on this Zoom is really interested. So I would say to all of you, go for science, go for it. So those questions, you got me with those questions. Yeah, so yeah, if you have an inquisitive mind, if you're really interested in finding out why things happen the way they do, then yeah, go for it. It's open to everyone. It's for everyone. Yeah, that's all I'll say about science.
Thanks. Well, thank you so much. And thank you for spending your time with us this half hour. And thank you to everyone who's joined in and asked really insightful and tough questions.
Yeah, it's been really fun. Thank you. And thank you for those questions. Yeah. What I can do is I can give you my email address. I don't know if anybody wants to send any questions afterwards or something.
Yeah, I think people would love that.
There's no chat function in here.
Oh, there's no chat. I think everyone can see it in the Q&A, but we can't add to the Q&A. Oh, it'll be a listening exercise. Read it out.
Right, what I'll do is I'll just share my screen and I'll put it text box. Okay. Oh, sorry, I'm just being a bit slow here. So it is just l.melbourne@bristol.ac.uk. So yeah, if anybody wants to send any questions to me or talk about careers or anything, I'm happy to take any questions. So you can just take that there.
And if you have any questions or want more information about career paths or renewable energy or CO2, definitely go to both the Geological Society's website and the Linnean Society's website, and I think you'll be able to get some great information there as well. And so with that, thank you so much, everyone, for joining us, and hopefully we'll see a few more of you at 5 too. So thanks so much. Thanks, Leanne.
Bye.
Bye.